So what's its appeal? Why is FT8 so popular? Well, with challenging propagation conditions, higher noise levels in urban environments, it's becoming a real issue. QRP, low power operation, and even compromised antenna situations, you can still have worldwide contacts using FT8. Now, I know that some hate FT8. They say that it's computers talking to computers, that there's no real human interaction. It's true that FT8 is not a conversational mode. It's sort of a bare essentials, a bare minimum exchange of information between two stations to effectively confirm a QSO, effectively confirm a contact. That's what it was designed for. Okay, so let's have a look at what a typical FT8 QSO would look like. So in my example here, I have got my call sign. I'm calling CQ. I send this as the first message, CQ VK7HH QE37, which is my grid square. That's the first thing that I would do, is I would call CQ. Then I would receive a signal back, or decode a signal back rather, VK7HH KM9G EN35. So that's Steve, KM9G, calling me with his grid square. Once I receive and I decode that, then the program would send KM9G VK7HH -10. I'm sending him a signal report of -10. Then he would respond back with VK7HH KM9G R -5. Now the R is Roger, I have received your signal report. Now the signal report, my signal report to you is -5, because of course I'll have the stronger signal. Then KM9G VK7HH, this is me transmitting again. I would send Roger, Roger 73. So I've confirmed everything and I've said 73s to acknowledge. Then Steve would send VK7HH KM9G 73, and that would be the end of the QSO. So that's a typical QSO. Now each transmit and receive sequence is about 15 seconds. So you can have a QSO in around about a minute or so. FT8 transmissions can be decoded -21 dB below the noise floor. Now, to give you some sort of indication, CW requires about another 10 or 15 dB to be able to copy. So it's a very weak signal mode. So that's a basic rundown of what FT8 is. So let's go over and jump into the software so that I can show you how to make a QSO. First thing, timing. Make sure that your computer has an appropriate time synchronization program installed. There's a lot of timing that goes into WSJT-X, and signals need to be within a second or so, otherwise they won't be decoded. So the easiest way to do that is to download a program. So I use NetTime, timesynctool.com here. It's free, and if I actually open it up, I can show you what it looks like. Here it is. It's going to synchronize again in another 4 minutes. Once you download it and install it, very simple. Just go to settings. You can leave the default host names here. You can change the time servers if you really want to, but I just change the update interval to every 15 minutes. I think this is set to every couple of hours by default. Just change it to 15 minutes and then it will update automatically for you, and your computer time should always be pretty good. FT8 was actually originally designed a mode which was designed with sporadic E signals in mind. So the reason why it transmits so quickly is because sporadic E signals can disappear really quickly. So on 10 meters and 6 meters, especially if you've ever used those bands during sporadic E season, all of a sudden the signal will be there and then the signal will disappear very, very quickly, and you don't have a lot of time to exchange contact information. So that's why when they developed the FT8 mode, it was really quick and it just happened to take off on HF. Everyone thought this was fantastic, and they started using it on HF instead. So it was originally designed for sporadic E, I think mainly on 6 meters sporadic E. The WSJT-X program can be found, all you need to do is Google WSJT-X. And you can download it here. There's, if we scroll down, there's downloads here for Windows, for Linux. This runs quite well actually on a Raspberry Pi. So if you've got one of those spare, you can install this and it will run quite well. Mac OS as well, and there's a couple of other Linux versions in there too. So everything's available on this website. There is a user guide as well. So if you go to, you can see here documentation. It's in all sorts of various languages. The user guide is very long. It is very detailed and includes pretty much everything to do with the software. If there's anything that you're not sure about, then consult definitely the user guide, and this will help you to set it up. It includes a very comprehensive, detailed description of what each mode is. So we won't go into it in detail here, but if you are interested in how the modes are modulated, what all sorts of specifications related to it, they are available on the user guide. All right, so I've started up WSJT-X, and I'll go through some of the settings that I had to set up when I first installed it. You can have a look at some of my settings and you can copy them if you want, if it makes it a little bit easier. So the first thing, once WSJT-X is installed, you do need to go into File and then Settings, and you need to configure your particular radio. So mine's an IC7300. Your radio might differ. I've also done videos on that on my channel as well, so check that out for the common radios such as the 7300, the 705, the FT991A as well I've also done. Now, because my radio is connected via USB cable, it creates a virtual COM port. So I've already looked that up, and mine is COM port 4. You can also hover over the COM ports here, and they will show you the what the actual COM ports are called. The baud rate is set in the radio. So on mine, I go into the menus and I set the baud rate to 19200. So you basically just need to set that to whatever is set in your radio. For my 7300, I've got 8 data bits, 2 stop bits, no handshake. All of this stuff you can Google to find your settings for your particular radio. Cat control is the way the PTT, the way the radio is keyed. Mode is data packet, because we're using the data packet mode on the radio. So what happens is, as soon as I fire up WSJT-X, the radio will go into the data mode rather than the USB mode, which is for voice. Under audio, so audio has the input and outputs for your audio. So basically your input is the audio that's coming out of your radio and into your computer. I've got that set to my USB audio codec, which is the one for my 7300. The output, excuse me, is to the speakers of the USB audio codec. So that's going from my computer into the radio. Frequencies, in here is all the standard frequencies worldwide that are set aside for various modes and regions. So you can see here that these are all added in. A common question I get is on 2 meters here in Australia, I don't think we have a standard FT8 frequency, and the software itself has 144.174, which is not the frequency. I think the most common frequency we use here is 144.320. So if you wanted to add that into the software, you can right click and go insert, and you can add a frequency in here. You can choose what the IRU region is, which just leave it as all if you want. And then you can select what mode for that particular frequency. So yeah, if I wanted 144.320, I'd type that in, change the mode to FT8, hit OK. And now if I went down here to 2 meters, you can see there I've got 144.320 now sitting in my frequency list. Apart from that, once you've got everything set up and you start receiving, the first thing you should look at is the signal meter down here on the left-hand side. Now you can see that mine is sitting at around about 66 dB. If you hover over that, it says 30 dB recommended when only noise is present, and at the moment it's receiving signals. If we turn up the radio, we can hear that we're hearing signals, so that's why that is quite high. So if you want just noise present, just disconnect the antenna, set it to about 30 dB and then go from there. Green is good, red's when it's clipping, yellow when there isn't enough audio. So you can adjust the audio appropriately coming into your PC. Now, the next thing to do is to go to mode and make sure that FT8 mode is selected. So we've got all the different modes, but the one that we're talking about today is FT8. So that will make sure that the program is in the correct mode for you to decode. Now you can see across this waterfall, there are lots and lots of signals at the moment. It looks like Europe is open. Now, I've done a few things here, just a very, very quick tip. You'll see some of these are highlighted in different colors. They've actually got the countries listed in here. If you go to File, Settings, Colors, here you can tick what you want to display in this window. So at the moment I've got, if it's a new DXCC, a new continent, also my call. So I think this is set by default, but just make sure. So by enabling that, it means that if someone calls you, you'll see it. Green is CQ and yellow is you transmitting. So that's just some of the basic settings that I've got set. So I can just look at that real quickly and I can say, oh, new DXCC, new CQ, new continent, etc., and I can go and work them. So that's the band activity on the left-hand side. On the right-hand side is the particular what you're receiving on your receive frequency. So you can see down here that I have a receive frequency of 1196 Hertz. Now that corresponds up here on the waterfall. You can see this little tab up here. There is a red marker and there's also a green marker. The green marker is your receive frequency and the red marker is your transmit frequency. And if you adjust it down here, say I put in 1500, then the green marker moves. If I move the transmit marker to also to 1500, the red marker also moves. Now you can also change frequencies by clicking. Now if you click at the top of the waterfall, that will only change your receive frequency. If you hold Control and click, this will change both transmit and receive. So transmit and receive will follow one another. So that's handy if you want to find a clear frequency, you can move very, very easily. And you can see there is a little drop-down box on the left-hand side. And what this does is has the pre-populated frequencies that are the frequencies that you run FT8 on. So in this case, we're running 20 meters, 14.074, and that frequency pops up in the little black box here. Now, if you hover over that, it says USB dial frequency, so upper sideband dial frequency. So with FT8, the radio is always run in upper sideband mode, and dial frequency indicates the frequency that you set your radio to using the dial. So that is the frequency exactly that we run FT8 on. In this case, on 20 meters, you set your radio to 14.074 megahertz. Now, the second part of that question is what's the relationship between this frequency in that black box and these two frequencies, the TX and the RX frequency. So as you can see there, hovering over those boxes, it has audio TX frequency and audio RX frequency. So to further explain that, if you have a look here at the waterfall at the bottom of my screen, you can see that this is showing the entire bandwidth from 0 Hertz up to 3000 Hertz. So what that is actually showing is the slice of bandwidth from 14.074 megahertz up to, because we're on upper sideband, up to 14.077 megahertz. So in that small slice of spectrum, we have all of our FT8 frequencies. You can see that they're all over the band here at the moment, and they're roughly around about 50 hertz wide. FT8, that's about for a signal on FT8, that's how much bandwidth is taken up in that spectrum. So we can fit quite a lot of signals into 3 kilohertz. In fact, we could run about 60, I think, transmissions if we space them out evenly every 50 hertz within that spectrum without them overlapping. Some do overlap because obviously not everyone knows what frequency someone else is on. But basically the way that you set this is, first of all, we'll look at the transmit, setting your transmit. You want to look here in the waterfall for a slice of spectrum that is free. So here you can see I'm sort of looking around about 2000 hertz. Oh no, there might be a station there. We can have a look around a little bit further, maybe about 2600. It looks like there was a transmission there, but it ceased. So if we go ahead and on Windows, you can hold Control and click, and that sets your little red marker and your green marker as well. And if we have a look now at TX and RX, we can see that it's set that correctly. Now that that's been set up, basically it means that I'll be transmitting and receiving on that particular part of the slice of spectrum, or that particular part of the band, not overlapping over anyone else. Now, one thing that's interesting, if you have a listen to FT8, all of those noises that you hear are the combination of all the different audio frequencies that people are transmitting at the moment. So because there's so many transmissions across the band and they're on all sorts of different frequencies, that's why it sounds a bit funny on the band. That's basically what this is. It's a visual audio representation of what's going on the band with respects to where each transmission is occurring. Now, my waterfall, as you can see here, it's not set up like this after you install WSJT-X. This is the way that I like the waterfall. You might be different, but I can see signals quite easily by just setting it up this way. So these are the settings that I've got. Bins per pixel 4. I start the waterfall at 200 Hertz. I set this just below 50%. What's that? Waterfall gain, just under 50%. Waterfall 0, I set just a fraction above 50%. I leave spectrum gain alone, and I leave spectrum 0. Spectrum is set to 30%. Default, palette, and cumulative. And then that's what we'll get there. So you get this nice representation of what's happening with the waterfall. And you can also drag this in and out to represent how far in the spectrum you want. But I usually leave it at about 200 Hertz to 3000. It's most of the signals are going to be in this range here. On the right here now, I've started to receive some signals on my receive frequency. Obviously, I've been moving it around while I've been doing this demo, but here we go. We've got here 1406, so I'm sitting roughly on 1406 up here in the waterfall. CQVK 4X1YS in Israel. I've never worked Israel before. I should be working him, but I'm doing this YouTube video. But anyway, all good. I'm sure I'll work Israel again another day. I haven't got them in the log. That's the basics of receiving signals that are current and seeing what signals are currently on the band. Now, as far as transmitting is concerned, when you double click on a station, so let's choose this Israel station, for instance. I don't want to transmit just yet, but the radio will start transmitting, and you can see here transmit, and it is sending that his call, my call, the grid square, like we mentioned before about the basic QSO. Now what happens is down here in the right hand side, it generates these standard messages. Now if you have auto sequence ticked, it will go through these one at a time as you receive the relevant signal back. So you can untick auto sequence and you can do all this manually, or you can leave that ticked. I recommend leaving it ticked because then you can follow along and you won't miss anything in case you get a signal report and you don't see it, because sometimes this window scrolls really, really quickly and you won't see it. So just leave auto sequence turned on. So what would happen is I would call him. If he heard me, he would respond with a signal report. This button would then jump down to Roger +6. And then he would send me a Roger 73, and then I would send a 73, and all that would happen within the space of a minute. QSO complete. So that's the basics of what responding to a CQ would be. Now, if you want to call CQ, you can see here that we've got all the frequencies listed, and it would take, you just wouldn't be able to keep up with what frequency is clear. So that's why the waterfall is really handy. So what I would normally do is if I'm calling CQ, I would find a spare spot on the waterfall. So up here, it looks like there's a couple of sequences here. There's a station maybe there, but it looks like it's rather clear in here. I would then move my frequency up to here, and then I would simply call CQ. And so just by ticking the bottom box down the bottom here, CQ, VK7HH, QE37, enable transmit, it would start transmitting. Now, call first here, if that is ticked, that will automatically respond to the first person that the software decodes that has responded to your CQ. So you might have 2, 3, 4, maybe a dozen stations responding to your CQ call. The first one that WSJT-X decodes will be the first one that it responds to. Once you've finished the QSO, it doesn't automatically go to the next station. It doesn't automatically start transmitting. Your transmit is actually disabled. So you have to go in and you have to set to call that other station that has called you initially with that CQ. So it's not an automatic thing where you can just leave it and it'll just make contacts all day while you're not sitting in front of the PC. So that's basically a CQ, calling CQ and getting a response. Now, there is a little button here, TX even first. Mine's currently ticked. The good thing about WSJT-X is that if you hover over any of these, it'll tell you what it is. So this will tell you whether to transmit in even numbered minutes or sequences, or to transmit in odd numbered sequences. And that's just to stop clashes between yourself and the other stations that you might be calling. On HF, it's not really that much of a difference because there's stations just transmitting on all sorts of odds and evens. But on the higher bands, on 10 meters and 6 meters, it might make quite a big difference because you don't want to be clashing with stations on the other end who might be transmitting at the exact same time as you because you're not going to decode them. Now, some people run into an issue with WSJT-X dropping out while the radio is transmitting. So the radio will be happily transmitting along for a little while, and then all of a sudden it throws a USB error, such as one that's displayed right up here, if I can find a screenshot. So the first likely issue that this is common mode current, which flows on the shield of the coax line while you're transmitting. Now, this can happen for a variety of reasons, but to stop it, I did do a video recently about using one of these, an FT, I think this is a 240. Might be a different model. Anyway, have a look at the video. I'll put a link up into the cards and also in the description below on building a common mode current choke, which you can put at the feed point of your antenna to stop or to reduce current flowing on the coax line and producing RF in the shack. Because what happens is the RF flows in the shack and can flow all over the place. It can make hum on your microphone. It can drop your USB out. I know I've had issues with this microphone before where I've been streaming and I have had common mode current and RF flowing around in the shack, and I've had hum and all sorts of things. I think I've fixed most of those issues now. So the first thing is to do a common mode choke or build a common mode choke. The second thing, and this is the thing that usually fixes the problem for me at least, is getting a high quality USB A to USB B lead. It's generally pretty high quality, I think. It's a printer cable, and you'll see here that it's got a toroid on the end of the cable. This toroid by itself does not fix the issue that I've also encountered. So what I did was I got I think this is, again, it's a mixed 240, a mix 43, FT240 mix 43, I think it is. And you'll see here that I've very loosely wound the USB cable around the toroid for, I don't know, half a dozen turns or something like that. Now, your mileage may vary, but this fixes the issue for me and I don't get those USB dropouts that I was getting before. Now, one thing that I will note while we're waiting for a station to respond to my CQ call, you'll notice here that there is a power slider. Now, at the moment, mine's set at around 50%. So this is the transmit audio level into the radio. So there's a couple of things to note with transmit audio into the radio. You don't want to overdrive your radio too much. Adjust the power level slider here in WSJT-X so that the ALC on your meter is at minimum or just a few bars at maximum, because you don't need a lot of ALC. You don't need it overdriving the radio because you'll cause distortion and all sorts of artifacts. In fact, here on the band here, I think this is some sort of artifacting going on over here. So some sort of distortion being caused just here. So that's probably as a cause of, because of overdriving the radios. Another way to make sure that your signal is clean and that you're not generating harmonics and rubbish all over the band is to go and turn on split operation. So if you go to File, Settings, go to your radio, and if it supports it, you can select rig or fake it. Now, why is this important? Well, I'll refer to the FT8 operating guide, which I'll put a link in the description below to, which gives you a lot of information in regards to FT8. But basically, this guide here says that depending on where your red goalposts sit above the waterfall, this function automatically adjusts both the radio VFO frequency and the audio frequencies so that the generated FT8 audio tones are toward the high end of the normal frequency range of SSB speech. Any audio harmonics then are more likely to be attenuated by the rig's transmit shaping filters, resulting in a cleaner, non-spooky, ghost-free transmitted signal. So that's basically what split operation means. That's if you set it to rig. If you need to, if your rig doesn't support it, you can select fake it. And what this does is the fake it settings automatically adjusts VFO-A to compensate for the different audio frequencies. So rather than using split VFOs on your radio, it will do it on one VFO and it will just adjust your frequency accordingly. 4X1YS has called me with his grid square. I've responded to him and I've said you are a +3 dB above the noise, which is a very strong signal. In fact, I can hear it in the speaker. Now let's see if he has got that. He said, Roger, I am -15. So I now send Roger, Roger, 73. And that's the contact. The contact is now complete. Being a weak signal mode, some people think that means QRP power only. Not necessarily. A good rule of thumb is only use the amount of power that you require to make a QSO. Just get a feel for how much band activity there is and just see how strong the signals are at the moment. So you can see here on 20 meters, I've got quite a few signals that are really, really strong. So I don't need to run a lot of power to work these stations. I set my radio to about 20 or 30 watts, and that's all I really need. Now, of course, you can run high power. You could run 500 watts, a kilowatt, but all you're really doing is you're just being a nuisance on the band. You're potentially probably going to cause splatter. You're potentially going to cause issues for nearby receivers that you might overload them because you'll be just so strong. And you're not necessarily going to be able to make the contacts because they might be able to hear you, but you won't be able to hear them because they're not running the same amount of power. So it's a delicate balance. Of course, that changes for things such as the high bands, 6 meters, 2 meters, and even above. Sometimes you need to run extra power because you need to be able to break through and be able to make that contact and make that QSO because the propagation is not there. So just gauge how much power you roughly need to be using based on the band conditions is a good rule of thumb. WSJT-X has many different modes for different purposes. Now, I did a video for beginners on that, so you can click on that here.